Hey guys, I'm Brian,
And I'm Jared.
and today we're going to show you how to find elevation using a laser level. A laser level can be used in construction to determine the elevation of any spot on your site relative to a predetermined location. By knowing the relative elevation around your site, you can better determine if your construction project is going according to plan. So first we'll show you the tools you need to perform the task. You'll need the laser sensor and the measuring rod, the actual laser level, tripod stand, and a data sheet that we'll show you later in the video.
In order to effectively use a laser level, you need to figure out the height of your instrument. To figure out the height of your instrument, you use the formula height of instrument, or HOI, equals benchmark, or BM, plus backsite, or BS. Your benchmark is an arbitrary elevation that you assign to a specific location on your site. All other elevations that you discover will be relative to the elevation of your benchmark. The backsite is the reading taken at the location of your benchmark. Now that you know how to determine the height of your instrument, we can move on to finding elevation. In order to find an elevation, you need two things: the height of your instrument and an intermediate foresight, or IFS reading. Once you have these two readings, you use the formula E equals HOI minus IFS to discover the elevation at a location. It is also possible to use a laser level to find out what IFS you will have at a specific elevation. This is especially useful when excavating a base. In order to find the IFS that you will have at a specific elevation, you use the formula IFS equals HOI minus E. When you determine your elevations, it is important to record them in a simple data sheet. Using a data sheet allows you to keep track of how your project is progressing. The data sheet should have these items: the name of the project you're working on, the date, the name of the person who's recording elevation, the location of the project, and any equipment that you're using. In order for us to demonstrate how to use the data sheet, first we have to generate some data.
So now we're going to show you how to set up your laser. To set the laser, first you'll need to set up the tripod. Try to set the tripod up in an area where it won't be bumped into or have to move during the construction process. Make sure you set the tripod in by stepping on the legs. Next, take your laser and attach it to the tripod by using the bolt attached to the tripod and screw it into the nut on the underside of your laser. After you have it attached, you can then press the on button. This will begin the self-leveling process of the laser. But once you press the on button, if the laser level will not self-level, then some adjusting of the tripod will be needed. This can be done by adjusting the legs on the tripod.
Now we're going to show you how to use the rod. To use the rod, you must first extend it. Once extended, you can then attach the sensor to it. To attach the sensor, you turn the knob in a counterclockwise direction to loosen it to the width of your rod, and then twist the knob in a clockwise direction to tighten it to the rod. To read the rod, first you must know the measurements. The rod is measured in meters, decimeters, and centimeters. Be sure to keep the rod as straight as possible, as this will ensure the most accurate measurement. The benchmark should be a stationary object that will never move. This object will be given an elevation. It should not be given an elevation of 0, because then you may have to work with the negative numbers. Today we're going to use the corner of the seams in the floor and give it an elevation of 100 meters.
Okay, so now that you know how to work the rod, we'll show you how to level it. Some rods come with a level built in. If you're using such a rod, ensure that you only take the IFS readings where the bubble is in the center of the level. If your rod does not have an attached level, you can level it by swinging it in a parabolic motion. How to read the sensor. Once the laser hits the sensor, your sensor will beep and give you a directional arrow in which way it needs to be adjusted to get an accurate measurement. The beeping of the sensor can also be an indication of the direction your sensor needs to go. Quick beeps means that the reading on the rod is high and the sensor needs to be lower. Slow beeps mean that the sensor is low on the rod and it needs to be higher. A steady beep means that it is level with the laser.
Back to the data sheet. Now that we have some data, we can enter it into our data sheet. Earlier we measured the backside at 1.025 meters. Our IFS reading from this pile of wood is 0.651 meters. Using the formula HOI equals BS plus 3M, the height of our instrument is 101.025 meters. Using the formula E equals HOI minus ISS, we can determine that the elevation of this pallet of wood is 100.374 meters. We hope that this video has taught you the basics of how to use the laser level to find the elevation of any particular spot by showing you the tools you need, the formulas, and how to use the tools and formulas. If you have any questions, don't hesitate to leave them in the comments section below. Thanks for watching.